We are starting with exercise 8G, question number 19. Okay, so y is equal to tan inverse of x upon root of a square minus x square. Okay, now see, tan inverse is there outside, that is perfectly valid for us. Okay, now here inside somehow we have to make this as tan, so that tan inverse and tan will get cancelled. Fine. So now see, here we are having minus x square. So whenever there is minus, we can use sine and cos. Okay. If it is plus, we can use tan. So better we use sine, because upper in the numerator, if we have sine, so sine upon down, if somehow it becomes cos, so sine upon cos will be tan. So let x is equal to sine theta. Okay. Let x is equal to sine theta. Now just remember, try to focus over here and understand one thing. There is this a present in the problem. Okay, so if any number is present in the problem, just put that number over here. So instead of just writing x is equal to a sine theta, so x is equal to sine theta, you can write x is equal to a sine theta. Okay, if it is root of 4 minus x square, you can put x as 2 sine theta, because 4 is 2 square. Okay, right? Once again, now see, there is minus x square. So whenever it is minus, use sine or cos. I am going ahead with sine. If it is plus, then use tan. Okay, and why we are putting this a? Because there is this number over here instead of 1. Instead of 1 over here, there is one number, that is a square. Okay, so the root of a square is a. So put x as a sine theta. Therefore, x upon a is equal to sine theta. Therefore, theta is equal to sine inverse x upon a. Understood? So y is equal to tan inverse of a sine theta upon square root of a square minus a square sine square theta. See, I'm putting this x square as a square sine square theta. In the next step, what I'm going to do is, I'm going to take a square common within the root. Okay, I'll take a square common within the root. So y is equal to tan inverse of a sine theta. So take a square common. It will be 1 minus sine square theta. It will be 1 minus sine square theta. Right? Okay, so this will be y is equal to tan inverse of a sine theta upon root of a square cos square theta. 1 minus sine square is cos square. So y is equal to tan inverse of a sine theta upon a cos theta. A will get cancelled. Sine upon cos will be tan. So this will be tan theta. So y is equal to theta. Okay. So y is equal to theta. What is theta? Theta is nothing but sine inverse x by a. Sine inverse x by a. Right? Now derivate this dy dx of y, which is dy dx of this. Now sine inverse x, the formula is 1 upon root of 1 minus x square. So this will be 1 upon root of 1 minus x. X is x by a. Okay. Into dy dx of x is getting replaced with x by a. So dy dx of x by a. So dy by dx is equal to 1 upon dy by dx is equal to 1 upon root of 1 minus x square by a square. Okay. And then this x by a, the derivative of x by a is 1 upon a. You can take 1 upon a outside, dy dx of x is 1. Okay. Take LCM within the root. So this will be a square minus x square upon a square into 1 upon a. Now you can give this root to numerator and denominator, right? So this will be written as dy by dx is equal to 1 upon root a square minus x square upon root a square into 1 upon a. Now root a square can be written as a. Okay, root a square can be written as a. So this a and this a is cancelled. So this turns out to be your final answer. Okay. Yeah, let us go to question number 21. Y is equal to tan inverse of x 1 plus root of 1 minus x square. Okay, now again there is minus x square. So we'll put x as sine theta. X is equal to sine theta. So y is equal to, and if x is sine theta, theta is equal to sine inverse of x. Theta is equal to sine inverse of x. Okay, yeah. So tan inverse of sine theta 1 plus root of 1 minus sine square theta. Okay. Now what is 1 minus sine square theta? 1 minus sine square theta is cos square theta. So y is equal to tan inverse of sine theta root 1 plus root of cos square theta. So y is equal to tan inverse of sine theta upon 1 plus cos theta. Now this is the same problem that we have solved in this particular exercise, question number 2, sub question 1. Okay, so you can solve it similarly. We have done this earlier in this particular exercise. Okay, let us go to question number 22. But then before that, once you simplify this, before derivating, put the value of theta as sine inverse of x before derivating. See, this is not the chapter of integration. It's a chapter of derivative. So derivatives, before derivating, you have to put theta as sine inverse of x. Okay. Next question. Question number 22. Y is equal to tan inverse of root a minus root x 1 plus root ax. Okay, now this is a very simple problem. It appears to be very difficult, but then it is very simple and straightforward. So root a minus root x. Now this part can be written as 1 plus root a into root x. Okay, so this will be a, this is b, and this is a into b. A, b, and a into b. Okay, so y is equal to tan inverse a minus tan inverse b. You know this formula, right? Tan inverse of a minus b upon 1 plus ab is tan inverse of a minus tan inverse of b. Tan inverse of a minus tan inverse of b. Now derivate this. Tan inverse of a derivative will be 0 because there is no x in this particular term. It's a constant. Tan inverse of root x. 1 upon 1 plus root x the whole square. See, tan inverse x formula is what? 1 upon 1 plus x square. So tan inverse of root x formula will be 1 upon 1 plus root x the whole square into dy dx of root x into dy dx of root x. Okay. So dy by dx equal to minus 1 1 plus x root x square is x. Okay. And this is 1 upon 2 root x derivative of root x. So this becomes your final answer, right? This is your final answer. Yeah. Now let us go to question number 23. Question number 23, just a second. Yeah, so y is equal to tan inverse of root of 2 minus x upon 2 plus x. So we have earlier discussed this 2 minus x upon 2 plus x. Okay, 1 minus x or 1 plus x upon 1 minus x or 3 minus x upon 3 plus x. You can simply put x as cos theta, cos 2 theta. Okay, always do that. But then put it along with a number. Whenever it is 2, you can write 2 cos 2 theta. Whenever it is 3, you can write 3 cos 3 theta. Okay, 3 cos 2 theta. Okay, so cos 2 theta is fixed, but then which number to put it ahead? Okay, the same number, right? So y is equal to, sorry, put x is equal to 2 cos 2 theta. Okay, therefore x upon 2 is equal to cos 2 theta. Therefore 2 theta is equal to cos inverse x upon 2. Therefore theta is equal to half cos inverse x by 2. Okay, this 2 will go down over here, half. Okay, So let's start putting x as 2 cos 2 theta. So y is equal to tan inverse of 2 cos 2 theta upon 2 plus 2 cos 2 theta. Okay. Yeah. Take 2 common in the numerator and denominator. 2, 1 minus cos 2 theta, 2, 1 plus cos 2 theta. 2 got cancelled. So tan inverse of 2 sin square theta, this 2 got cancelled. Again, I'm applying half angle formula. And this is 2 cos square theta, 2 got cancelled. So this is equal to tan inverse of root of tan theta, tan square theta. Okay. So eventually this will be tan inverse of tan theta. Okay. Tan inverse of tan theta. Tan inverse and tan is getting cancelled. So y is equal to theta. And what is theta? Before derivative, we have to put the value of theta. The value of theta is half cos inverse x by 2. Okay, so this is half cos inverse x by 2. So dy by dx is equal to half will remain as it is. Cos inverse x derivative. Cos inverse x derivative is minus 1 upon root of 1 minus x square. Okay, so cos inverse x by 2 derivative will be minus 1 upon root of 1 minus x by 2 the whole square into dy dx of x by 2 because x is getting replaced with x by 2. Okay, now we need to simplify this further. That also I will do it for you. Dy by dx is equal to half minus 1 upon root of 1 minus x square by 4 into half. Okay, into half. So this x by 2 derivative is half. This half is also written and this is written as x square by 4. Okay. So this will be 1 by 4 minus 1 by 4 into 1 by root of 4 minus x square by 4. So that is minus 1 by 4 into 1 upon root of 4 minus x square upon root of 4. Roots can be split in division. 1 by 4, 1 upon root of 4 minus x square upon 2. Okay, root of 4 is nothing but 2 over here, right? So this 4 and this 2 will get cancelled. So this is your final answer, 1 upon 2 root 4 minus x square. Okay, let us go to question number 24. Let us go to question number 24. Okay, y is equal to sine inverse of 2 raised to x plus 1. Now this is totally based on indices. 1 plus 4 raised to x. Okay, so sine inverse of 2 raised to x into 2 raised to 1. Guys, if we multiply this, the powers will get added and it will be 2 plus 1, x plus 1. Okay, so that's the reason why we are splitting this. Okay, 1 plus 4 is written as 2 square. Okay, so this is step number 1. Now in the next step, what I'm going to do is I'm going to write this as 2 and I'll place it over here. And this, I'm going to put x inside and 2 outside. X inside and 2 outside. Okay, so sine inverse of 2 into 2 raised to x plus 1 plus 2 square raised to x. Okay, now this is a specific, sorry, I just wrote x. I should write x inside and 2 outside. That is what we have discussed in the previous slide. Okay, now understand the pattern over here. Okay, so it is something like 2 tan theta upon 1 plus tan square theta. Okay, so this is sine 2 theta. But then look at the pattern. Pattern is this. So at the back of your mind, all the formula list should be, entire formula list should be there, right? So y is equal to sine inverse of 2 tan theta upon 1 plus tan square theta. What we are doing, we are putting 2 raised to x as tan theta. So I'll just write it over here. Let 2 raised to x is equal to tan theta. Okay, we cannot put sine cos over here because it will not follow any pattern if we put sine and cos. If we put tan, we get this pattern of half angle. Now 2 tan theta upon 1 plus tan square theta is nothing but sine 2 theta. Okay, this is the half angle formula of sine 2 theta. I hope you are understanding this. Okay, so this sine inverse and sine will get cancelled, and then you are left with 2 theta. You are left with 2 theta. Okay, y is equal to 2 theta. Y is equal to 2 theta. What is theta? Theta is nothing but, from here we can get the value of theta. Theta is nothing but tan inverse of 2 raised to x. Okay, take tan on the other side. So I'll just write theta is equal to tan inverse of 2 raised to x. Before derivating, we have to do this. So d by dx of y, d by dx of this right hand side. So 2 will remain as it is. Okay. Tan inverse of x derivative is 1 upon 1 plus x square. So tan inverse of 2 raised to x derivative will be 1 upon 1 plus 2 raised to x the whole square into d by dx of 2 raised to x. Because x is getting replaced with 2 raised to x. Okay. Now 2 raised to x derivative is 2 raised to x log 2. So dy by dx is equal to 2 upon 1 plus 2 raised to x the whole square into 2 raised to x log 2. Okay. So 2 into 2 raised to x log 2 upon 1 plus 2 raised to x the whole square. This is the final answer. You need not simplify after this because it is almost the final answer. There are few things which we can do over here, but then of course we can stop it over here. Okay. So we'll continue with question number 25, sub question 1. Okay. So y is equal to tan inverse of 1 plus x square plus x. Okay. So y is equal to, see now there is plus x square. So whenever it is plus x square, okay, put x is equal to tan theta. Put x is equal to tan theta. So y is equal to, then this gives me theta is equal to tan inverse of x. Okay. So y is equal to tan inverse of 1 plus tan square theta. Okay. Plus tan theta. Y is equal to tan inverse of, what is 1 plus tan square theta? It is sec square theta plus tan theta. Okay. So y is equal to tan inverse of sec theta plus tan theta. See, had it been minus x square, then we will put x as sin theta or cos theta. Okay. Now sec theta and tan theta will convert it into sin and cos. So y is equal to tan inverse of 1 upon cos theta plus sin theta upon cos theta. Okay. So y is equal to tan inverse of 1 plus sin theta upon cos theta. Okay. Now 1 plus sin 2x is equal to cos x plus sin x the whole square. Okay. You know this particular formula, right? This is similar to the problem number 2, sub question 2. Okay. Problem number 2, sub question 2, something like that. Okay. So just a second. It is similar to problem number 4 from 8G. Okay. Now cos 2x. Cos 2x is equal to cos x minus sin x the whole square. There are 4 formulae. But then why am I using this formula is because I have to involve both sin and cos. Okay. So this both formulae, two formulae we are going to apply in the numerator and the denominator respectively. So this will be tan inverse of, okay, cos theta by 2. Theta becomes theta by 2, half angle, the whole square upon cos theta by 2 minus sin theta by 2, the whole square. Okay, just a second. I have written the formula wrong over here. Sorry. This is cos square x minus sin square x. Okay, and this is cos square theta minus sin square theta. Right? Please excuse me for this. Yeah. So at the top, we are going to write a plus b the whole square as a plus b into a plus b, and down a square minus b square as a minus b into a plus b. Okay, so we applied half angle at the top, half angle at the down. Formulae are written on the right hand side. See both the formulae, and theta becomes theta by 2. So y is equal to tan inverse of cos theta by 2 plus sin theta by 2 into cos theta by 2 plus sin theta by 2, and down a square minus b square. So a is nothing but, I'll show you what is a. A is cos theta by 2, b is sin theta by 2. So a minus b, a plus b. So cos theta by 2 minus sin theta by 2 into cos theta by 2 plus sin theta by 2. Okay, so this and this will get cancelled. Now this thing, cos theta by 2. We'll make this particular value 1 by dividing throughout by divide throughout by cos theta by 2 with the same value. We have to make this one because outside we are having tan inverse. So tan inverse of, divide all these values by cos theta by 2. So cos theta by 2 upon cos theta by 2 is 1. Sin theta by 2 upon cos theta by 2 is tan theta by 2. Okay, down cos upon cos is 1 minus sin theta by 2 upon cos theta by 2 is tan theta by 2. Okay, so this is what we have got. Now this particular thing, we are going to rearrange this. Okay, here we'll write this one separately and we'll put 1 over here. 1 into tan theta by 2 is tan theta by 2. Okay, so all these things we are going to do. So now y is equal to tan inverse of 1 plus tan theta by 2, 1 minus 1 into tan theta by 2. Okay, so this will be A, this is B, and this is A into B, right? So y is equal to tan inverse of A plus tan inverse of B. Okay, tan inverse of A plus B upon 1 minus AB is tan inverse of A plus tan inverse of B. So tan inverse and tan will get cancelled. Tan inverse of 1 is 45 degree plus theta by 2. So 45 degree theta. What is theta? Theta is equal to tan inverse of x upon 2. Okay, we have written theta as tan inverse of x, right? Okay, see, so dy by dx, derivative of 45 is 0, tan inverse of x upon 2. So out of this, half will come outside, and derivative of tan inverse of x is 1 upon 1 plus x square. So half into 1 upon 1 plus x square. So this is equal to 1 upon 2, 1 plus x square. So that was your question number 25, sub question 1. Okay, let us go to question number 25, sub question 2. Okay, y is equal to cot inverse of root of 1 plus x square minus x. Okay, don't play with cot, play with tan. So this is tan inverse of, take the reciprocal in the denominator. Sorry, take the reciprocal of the bracket. So the term moves to the denominator. Now this is plus x square. What we'll do is put x is equal to tan theta. If it is minus x square, we'll put x is sin theta or cos theta. So this gives me what? Theta is equal to tan inverse of x. So y is equal to tan inverse of 1 upon root 1 plus tan square theta minus tan theta. Okay. So this further we have to simplify. Y is equal to tan inverse of 1 upon root of sec square theta minus tan theta. Okay. Root of sec square theta is sec theta. So this is sec theta minus tan theta. Okay. Now convert it into sin and cos. So tan inverse of 1 upon 1 by cos theta minus sin by cos theta. Okay. We have a common denominator over here, that is cos theta. So tan inverse of 1 upon 1 minus sin theta upon cos theta. Okay. So tan inverse y is equal to tan inverse of cos theta upon 1 minus sin theta. So 1 minus sin theta, we are going to use the formula of 1 minus sin 2x, which is 2, which is cos x minus sin x d whole square, and cos 2x. This cos 2 theta is cos 2x formula. So that is equal to cos square x minus sin square x. Okay, right? So y is equal to tan inverse of cos square x by 2 minus sin square x by 2. Sorry, theta by 2, because theta becomes theta by 2. And down it will be cos theta by 2 minus sin theta by 2 the whole square. Okay, now at the top you can use a square minus b square within the square bracket, and down a plus b the whole square, that is a plus b into a plus b. So y is equal to tan inverse of a square, a plus, one second, let me just go back. On the top it is a square minus b square. So what we are going to do, a minus b into a plus b. So a minus b into a plus b upon, down it will be, let's see what we have to write, a minus b the whole square, which is a minus b into a minus b, a minus b into a minus b. Okay, so this terms are getting cancelled. Outside we are having tan inverse. So now you have to divide throughout by cos theta by 2. Okay, and then rest of the problem you can solve, because now this category of problems we have solved many times. So I would insist that you do some practice of this. Each and every term, you divide it by cos theta by 2. Whatever is this term, now with that term, okay, the one which I'm marking in red, whatever is this term, we should divide this term with each and every other term wherever we are having tan inverse outside. The purpose is to make this 1. Okay. Let us go to question number 26, sub question A. Right? So question number 26, sub question A, y is equal to tan inverse of root of 1 plus x square plus 1 upon x. Okay, now we are having plus x square. So let's put x is equal to tan theta. Let x is equal to tan theta. So theta is equal to tan inverse of x. Therefore, y is equal to tan inverse of root of 1 plus tan square theta plus 1 upon tan theta. Therefore, y is equal to tan inverse of sec square theta root, take a root above it, upon tan theta minus plus 1 upon tan theta. Okay, so this will eventually be y is equal to tan inverse of sec theta plus 1 upon tan theta. Now convert everything into sine and cos. Y is equal to tan inverse of 1 upon cos theta plus 1 upon cos theta plus 1 upon sin theta upon cos theta. Okay, so this will be tan inverse of 1 plus cos theta upon sin theta upon 1 plus cos theta upon cos theta, sorry, upon cos theta, the whole upon sin theta by cos theta. So I've taken LCM over here. This part I've taken LCM. Cos and cos will get cancelled. So what we are left with, y is equal to tan inverse of 1 plus cos theta upon sin theta. Now this is very similar to some of the problems we have done earlier. Okay. So 1 plus cos 2x formula. So 1 plus cos 2x is 2 cos square x. Okay. So y is equal to tan inverse of 2 cos square, theta will become theta by 2. And down, sine 2x formula. Sine 2x is equal to 2 sine x cos x. Okay, so 2 sine theta by 2 cos theta by 2. Okay, so 2 got cancelled, square and this cos got cancelled. So we are left with tan inverse of cot theta. So y is equal to tan inverse of cot theta. Now cot and tan occur in pairs. So cot theta by 2 can be written as tan pi by 2 minus theta by 2. Tan pi by 2 minus theta by 2. Tan inverse and tan will get cancelled. So this will be pi by 2 minus theta by 2. And what is theta? Theta is nothing but we already have taken theta as something. Tan inverse x. Okay. So theta is tan inverse x by 2. So dy by dx, derivative of pi by 2 is 0. Derivative of tan inverse x by 2. So take half outside. Derivative of tan inverse x is 1 upon 1 plus x square. So minus 1 upon 2, 1 plus x square. Understood? Okay. Yeah. Question number 2. Question number 27, sub question 2. Fine. We'll solve this problem right now. Just a second. Yeah. Question number 26, sub question 2. Sorry. Earlier it was 26 sub question 1. This is 26 sub question 2. Y is equal to tan inverse of root of 1 plus a square x square minus 1 upon ax. Okay. Now see, look at the arrangement over here. Tan inverse of root of 1 plus ax the whole square minus 1 upon ax. Now we are having plus ax the whole square. So it is, whenever it is plus, take tan. But then we'll club this a along with x. So put ax is equal to tan theta. So theta is equal to tan inverse of x. Okay. So y is equal to tan inverse of root of 1 plus tan square theta minus 1 and ax is tan theta down. Wherever there is ax, put tan theta. Okay. See, wherever there is ax, put tan theta. Fine. So now this is similar to the previous problem. Tan inverse of 1 plus tan square is sec square. Sec square root is sec theta minus 1 upon tan theta. Now you can convert into sine and cos. Take LCM, cancellation of few terms, and then the problem is going to be very simple. Okay. Right. So after this particular point, you can solve it for self-study. Just remember one thing, before we derive towards the end, replace the value of theta before we derive, not after we derive. Okay. Yes. Now let us go to question number 27. Just wait. Question number 27. Y is equal to sine square of cot inverse of 1 minus x upon 1 plus x. Okay, never play with cot inverse, convert it into tan inverse. So the terms within the root also will be reciprocated. Okay, so reciprocal of this and reciprocal of this. See, within the root I have taken reciprocals. Now 1 plus x, 1 minus x, this format will put x as tan theta. X as cos 2 theta, sorry. Will rely on half angle. Therefore, 2 theta is equal to cos inverse of x. Therefore, theta is equal to cos inverse of x upon 2. Right? So x y equal to sine square tan inverse of 1 minus cos 2 theta 1 plus cos 2 theta. Okay. So y is equal to sine square tan inverse of what is 1 minus cos 2 theta? 2 sine square theta. Okay. 2 sine square theta and 1 minus cos 2 theta is 2 cos square theta. I think I have messed up with the sign over here. It should be plus up and minus down. Sorry for that. Okay, and then I will be taking a new slide instead of writing over here. Okay, so in the numerator, we are having 1 plus cos 2 theta. Okay, now this 1 plus cos 2 theta is 2 sine square theta, 2 cos square theta. Okay, half angle formula. So y is equal to sine square tan inverse of root of 2 cos square theta, and down we are having 1 minus cos 2 theta. So 1 minus cos 2 theta in the denominator over here. That is 2 sine square theta. Okay, 2 sine square theta, right? So 2 and 2 is getting cancelled. So y is equal to sine square tan inverse of root of cot square theta. Okay, so y is equal to sine square tan inverse of cot theta. Okay, now tan and cot occurs in pairs. Okay, so I will write this as, I'll write this cot as tan pi by 2 minus theta. So y is equal to sine square into into tan inverse of, just a second, cot pi by 2 minus theta. Okay, now cot pi by 2 minus theta is nothing but tan theta. Okay, tan inverse and tan is getting cancelled. So y is equal to sine square theta. Okay, now at this particular point, we can make the problem very simple. Just multiply and divide with 2. Remember this last few steps. They are a bit tricky, but then it will make the problem very simple. Okay, multiply and divide by 2. Now what is 2 sine square theta? Okay, just think over it. What is 2 sine square theta? Two sine square theta. It's a part of the half angle, right? Where we get this particular format, 2 sine square. One second. I think I need to check a few steps ahead. Uh, this particular thing, cos square upon sine square is cot square. This is cot theta. And this is cot pi by 2 minus theta. I think I just made some copying mistake. Cot pi by 2 minus theta. Okay. This, one second, I'll just erase this particular slide. Sorry for this. Yeah, so we are at this particular point, everyone. Okay, I'll just copy this on the next slide because I don't want to make any error. I just made some copying mistake. Y is equal to sine square. Okay, what we got? Tan inverse of cot theta. Tan inverse of cot theta. Okay, so we had got this. Okay, now cot theta can be written as tan pi by 2 minus theta. Okay, tan pi by 2 minus theta. Now tan inverse and tan is getting cancelled. Okay, so sine square pi by 2 minus theta. Take the square outside, sine pi by 2 minus theta. Okay, let's take the square outside. What is sine pi by 2 minus theta? It is cos theta, the whole square. So y is equal to cos square theta. Okay, y is equal to cos square theta. Now let's take this on the new slide. Y is equal to cos square theta. To make the problem simple, what I'm going to do is I'm going to multiply and divide with 2. Okay, just a second. Okay, so what is 2 cos square theta? It's half angle. 1 plus cos 2 theta by 2. Okay, and guys, if you remember, at the start of the problem, we had taken excess cos theta. Okay, we had taken excess cos theta. I'll just show you where I had taken that. X is cos theta. So cos 2 theta at the very end, I'm going to replace this cos 2 theta with x. Okay. So this is equal to half into 1 plus x. Now derivate this dy by dx, half will remain half because it's multiplication, and this will be 0 plus 1. D by dx of 1 is 0, x is 1. So the answer is half. That ends this particular exercise. Last problem, I made some copying error from the previous slide. So you just make sure that you go through the problem once again. Okay, thank you.